Hey team, starting video 3 of our binary search series. And in this video, we get to start actually programming this algorithm. So we get to look at what this looks like in the code. So let's get started. Okay, so here I have created just the basics of a class. So I know that there's a lot of squigglies. It's just because I'm not following our appropriate linting rules. It thinks that these are magic numbers and this is a magic number, and it wants me to add comments. So I hope those aren't too distracting for you. We're just ignoring them for now. So let me show you what I have written. I have created an integer array that we've called the haystack. We've got the needle, so this is the thing that we're looking for. We are trying to find the value 67 here in the haystack. And then we are trying to find the index. Where is that needle in our array in the haystack? And so we're going to call binary search with that and send in the haystack, and we send in the needle. After that, we're going to print it out. So here is our binary search method. It accepts the integer array and the needle. Right now, it has to return something or it's going to look like it's an error. So we're just returning 0, but we will want to return something different than that at the end of this. Okay, so I've also added some comments for the things that we need to do as we proceed on this adventure. So the first thing that we did when we were looking at the algorithm is we set the high value and we set the low value. So we want to set those initially, and then we want to start doing the loop in the actual search. So let's start with setting the high and low values. Remember that high and low are indices into an array, and array indices are always ints. Int singular. So int high is going to be, remember, high is going to be the very last index in our array. And the last index of an array is the length of the array. So haystack dot length minus 1. So the length, because it's 0 indexed, we need to subtract that 1 to get the index of the last element. We also need to set low. Int low equals the first element in the array. So that equals 0. Okay, so we have those values set. Now, what we need to do is we need to set up the parameters for our loop. Now we have to also decide what kind of loop we're going to write. And in this case, we are going to write a loop that we don't really know how many times it's going to iterate. And we're not like iterating through it linearly like we would if it was a for loop. So this is speaking to me in while loop language. So let's write a while loop. And when was the time that we were going to stop looping through the algorithm? When did we say that whether we found it or not, this was the last step? Do you remember? Okay, we said that we were going to stop when high equals low. Like when high equals low, that was the last time that we were going to look. And we know that high is always greater than low. So what if we said something like while high is greater than or equal to low? Added a space there. Okay, so while high is greater than or equal to low. So this means it's going to loop, is going to loop until high equals low, that's going to be the last time it loops, and it's going to exit after that. Okay, so now we are inside our loop. We know that we're going to enter right away because even if there are no elements in the array, we're going to say 0. Anyway, okay, so we need to set mid. So I said we were going to just take the simple midpoint, which is high plus low. You want that to be in parentheses over 2. Okay, so this is going to find our midpoint, high plus low over 2. When high equals low, this is just going to give us the same value as high and low. So we have now set our midpoint. Okay, this was all the easy stuff. Now I need to start figuring out like what are the different possibilities. Can you pause this video, take a second, and think about what are the different possibilities of what we might find at mid? What do we need to consider? Pause. Okay, so I thought about it and what we need to do, the things that we should consider are, so what if we actually found what we're looking for? That would be awesome. Okay, so that is one option. Then what if needle is less than mid? I'm going to write it out in words so I don't have to think in math symbols. Okay, so what if needle is less than mid? And our only remaining option is needle is greater than mid. Okay, and then after that, we can end the loop. So let's go to each of these opportunities. So if we actually found what we were looking for, what would that look like in code? So we have if, and we know it's needle. So if we found what we're looking for, that means that the needle is at index mid. So we could say if needle equals, and now we can't just say mid, because if needle equaled mid, that would mean that needle equals the index, and we don't want it to equal the index. We want it to equal the value at the index. So we'll say haystack at mid. So if mid, which is the you are here sort of value, if it equals, that's fantastic. If it equals mid, then we've found what we're looking for and we don't need to do anything else. So we're ready to return here. What value should we return? Take a second, pause. Okay, if you remember, our binary search is going to return the index of the value, the index of the location of the needle in the haystack. So here we have found that our needle can be found at haystack mid. So we're going to return mid here. Mid is the index where the haystack holds the needle. Perfect. That was super easy. So now what if our needle is less than mid? So I can else if here. So else if needle is less than the value at mid. So here we can just replicate what we did up here. If needle is less than our value at index mid, then now what? Okay, so if the needle is less than haystack at mid, this means that we are moving to the left. So in this array, let's say, I'm not counting fully, but let's say this is what we were looking at. So we have high is 2, we have, or excuse me, high is 98, low is 2, and our mid is the index that's pointing at 35. Well, we know that the value in this fictional scenario where we know that our value is less than mid, we know it's not 35. So we are going to move our high value to one less than the index of 35. And that should be enough. So if needle is less than haystack at mid, then we need to, oh, we don't want to return because we haven't found the thing yet. We just want to reset the value high. So high equals mid minus 1. This just means we are taking our high that was right here and we're moving it here. Okay, so we have that. Now if needle is greater than, well, our only option is that it's greater than, right? So our needle is greater than the value at mid. And if that is the case, so if what we're looking for, like 67 that we're looking for here, if this is our original value of mid, then we know that what we're looking for is going to be somewhere between the item just to the right of mid and the end. So our high doesn't need to change, but in this case, our low does change. So our low is going to change to 46. So here we are going to say low, our low is going to be reset to mid. This time we're going to do +1. So this is the case, again, where we decide it's to the left, or excuse me, it's to the right, and it doesn't include the element that we just looked at. So we're going to move our low to the one next to that. Okay, and really that's all that's necessary here in the loop. So we have mid equals high plus low over 2. This is where we set the mid. Then we have the different situations of what we find about mid in relation to the needle that we're looking for. So if the needle equals the value at haystack at mid, then that's perfect. We found the value that we're looking for, which is the index of the needle. We found it, so we just return mid. Otherwise, if the needle is less than the value at mid, then we are going to move our high to be one to the left of our current mid. If the needle is greater than the value at mid, we are going to go to the right. Low is going to move to the right. Okay, and then we end the loop. Here, if it wasn't in the array, we need to return high equals low equals 1. Okay, so here we have high equals low. Here we are going to Hmm. I think we might need another case here. So what I'm seeing is that what if we don't find it? Let's say we don't find the item that we're looking for in the array. So that means that we are going to get to a point where high equals low equals mid. And if that's the case, we are setting needle equals haystack, or if this, okay. So if high equals low, we do go into the array, we set, or go into the loop, we set our mid. This fails because our value is not there. This could be the case. Maybe our needle is less than haystack at mid, but maybe our needle is greater than haystack at mid. And if that's the case, we're going to be modifying either high or low. So it's going to be really hard to figure out which element it is that we're looking for down here. So let's add another if statement at the beginning. So let's say, what if high equals mid equals low? So I'll say if here, high equals low. We don't really need to check for mid. This is enough. So if high equals low, then this is where we are going to check this again. I might need to refactor this later. Actually, let's do it better than this. Okay, so we have high equals low here, and we only want this to execute if this is not true. So we only want to send our value, the -1 here, if this is false. So if needle does not equal haystack. So this is saying if we are in our last iteration and needle does not equal the haystack, so our last chance, it's not equal, then what we want to do is we want to return, we could return high, we could return low, we could return mid, any of those, they have the same values, so it doesn't matter. But we return mid here. So let's use mid. So what we said when we were talking about the algorithm is we would return negative the value. So we could use any, I'm using mid here, -1. Okay, so okay, now this part here, we're never actually going to reach. Okay, let me walk you through this algorithm one more time. Okay, so here we have high equals haystack at length -1. This means that we have the last element in the array. Low equals the first element, or the first index in the array. That means we have high is less than or equal to low. And That is true at the beginning. So we're going to loop there. Then we set our midpoint to be the midpoint between high and low. Now there are a couple of options of what could happen here. So if high equals low, this is if we have found we're at the last state and we have not found our element. So we are in our last final option. We have not found our element. We're going to return negative mid minus 1. This means that we're going to return like where it would be inserted into the array. But we're sort of like adding our last final case at the beginning. So let's go back to what if we found what we were looking for? So if at this element, this mid, we found to the needle, that's great. We just return mid. So we found it. Perfect. These are our end game scenarios. They could be in any order. We have them in this order, but it doesn't matter. Okay, so then here, if our needle is less than the item at mid, then we're going to move our high to the left of mid. So we can only focus on the elements in the half of what we're considering right now that is less than mid. Otherwise, the needle is greater than the value at mid, so we can have low equals mid plus 1. So this means we are moving low to be 1 greater than where we previously were, because the element that we're looking for is greater than mid. And then we end the loop. Our array is going to return one of these two things. So it's always going to return early, and we're never actually going to finish the loop. So I have to add this return 0 in order for the code to compile, but we're not actually going to reach that. Now I'm going to run this code to make sure that it works. Hopefully I can do that here. Run Java. Yes, okay, we get an answer. The needle is at index 13. Let's count. 1, 2, or sorry, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Indeed, it is what we're looking for. Now, what if we're looking for an element that does not exist in the array? So 68 is not in the array. Let's see what happens then. The needle is at index 0. Okay, that's not what we want. Okay. So here, I'm going to add just a little bit of print debugging here, just to keep track of things. I am going to write system.out.print, and I'm going to say hi, mid. I hope that you see that I am just a human as a programmer, and I make mistakes too when I'm just trying to write this from memory. So plus space high. This will help us understand what's going on in our loop and if our high and low are behaving as they should. Okay, so we start at high is 2, and high is at index 0, and low is, excuse me, low is at index 0, high is at index 15. Then we have index 7, but what we're looking for is 68, so we move our low to 8. That is correct. So we move our low to 8, and our high is still 15, which makes our mid 11. So now we are looking here, and our value 68 is still greater than 11. And so we move to 12. So we have low equals 12, mid equals 13, low equals 12, high stays the same. Our mid equals 13. So that means we are looking at this value. This is our mid. We want to go greater than that. So we look then, we have index 14 and high is index of 15. Our mid is 14. We consider, and we should be modifying high to go down 1. So why is it not doing that? I'm going to add a little bit more here. Um, just so we can better keep track of run it one more time so that we have clearer output as we look around. Okay, so all of this is correct. So if we have our low equals 14, mid equals 14, the value at mid is 70. So that means that because what we're looking for is 68, then our needle is less than the haystack at mid. So our high should be decremented by 1. I'm going to print this both here and at the end of the loop so we can see how things changed. And I'm going to add an extra new line so we can keep things straight. All right, let's run it again so we have better output that we can deal with. Okay, so in this case, this is a really interesting case. So we have our last time that we go through, we do not have the two values never ended up equaling each other. So our mid was 14, which was the same as low. So when we modified high, our high actually became less than our low. This is because we have an even number of elements. I think it's because there's an even number of elements. It's really just how it worked out. But this was a case that I didn't consider when I was writing the algorithm. So maybe this needs to be outside. Huh. Okay, so seeing me debug in real time. All right, so here we know here trying to figure out how to do this without repeating myself. But anyway, so that is not what I meant to copy. So I want that, and I want it down here. Here, we can return either of them. It could be high, it could be low. Let's use low because you can see that it is more accurate to where it should be. So here, the values that we have are, this is 13, this is 14. So low is 14, or low is 67, high is 70. I think it makes sense if we were going to add it, we wouldn't add it here because then 67 would be moved over. We would want to add it in this space. So if we get to the end of this array, that means that high either equals low or it is less than low. So I'm having a hard time reasoning this right now. So I'm just going to, we want the max between high and low, which at this point, as I said, high is either going to equal low or high is going to be less than low. So if I return low, that is guaranteed to be the maximum value or the same value as high. So I'm going to return negative low minus 1. I think that's right. I don't know. Let's see. So then we can have an else. I don't think we need an else because that's already taken care of in here. So let's see. We may not need this if statement at all. Let's run it and see what happens. Uh-oh. We still need that return 0, even though it should never happen. Still getting, oh, that's because we're still checking if high equals low. We need to get rid of this. You guys are probably watching it and being like, ah, I see the error. I see the error. Okay. All right. So here, the high is at index -15, which is exactly what we are looking for because that equates to index 14. 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it should be inserted here. We have written -15, which is perfect. I hypothesize that this is not, the if statement is not necessary. So let's say, what if we haven't found it? Then we want to return the negative index. Okay, so the needle is at index -15. That's exactly what we wanted. Let's search for 100 instead. Make sure that it works. Okay, the needle is at -16, which is perfect. So it would be here. It would need to be inserted at this last index. Okay, what I would like you to do is pause this video And I want you to trace out what it would be like to look for element number 4. Look for element number 4. I will show you as much of this code as I can. It's getting kind of small. Sorry, guys. But here is the whole algorithm. Trace 4 for me. Come back when you finished. Okay, if you are back, I'm going to make this bigger again so we can see what happens. I am going to change this value to 4, and you'll be able to see how our array, how our binary search works. Okay, so when we were looking for value 4, we started with low at 0, high at 15, which is exactly what we should do. Then we have low stays at 0. We move high to 6. We're looking on the left side. Here, low equals 1, high equals 2 because we moved to the left side of 3, and mid then equals 1, which is exactly where 4 is. C value at mid is 4, and the needle is at index 1. Thanks, team, for going on this adventure with me. I apologize that it was kind of wandering, but we got what we needed in the end. Thanks, team. See you in next video, part 4.